Good afternoon, it's Tony with another update real quick. I'm going to be talking about something a little bit different today, which is the artificial sun module subsystem and some things that I'm kind of working on with that. I'm just picking apart different areas and trying to eventually put it all together and see where I'm at. Try a couple different things that I thought were really interesting to work on. So we could talk about this first. What I had done was, this is a couple different layers here. Everything here is custom built and machined and milled to my own specs. So this X configuration, originally I wanted to do a Y configuration of the LED sequins, which have a quantified dominant wavelength as per the user manuals or product description guides, technical documentation. So the reds being about 625 nanometers, etc. So because of the way the PCB was lined out and I had to cut this out, what I had done was I decided to throw in white in there. So I've got red, green, blue, and white in different configurations. I have it all wired up. As you can see here, I've already assembled a lot of this stuff, but it's quite some intricate wiring here. This video just doesn't do it justice until you see it up close in person. So there's two different layers. Something I've kind of dubbed as the STAR, which is a solar test array. The layer one would be whatever's mounted to the 5 milliwatt laser that's used as a calibration tool, and very, very accurate. It kind of provides, like what I talked about before, just some precision measurements and showing you exactly how to show exactly where your array is pointed. So I added a couple different sensors here in the second layer. This one is the VL53LOX. It's a breakout board that comes already pre-made, but integrating it is a whole different story, as I found out. What happens is this tiny little black box, it might be kind of hard to tell, is actually a send and receive capability, minimal cone distortion as it gets towards its object, and it actually gives you very precise distance measurements. And what I'll do is, because of the distance between here to here, I'll actually take my digital caliper and incorporate that distance into the code, so it'll actually show from the very top of the LED, basically the emitting source, so you can get accurate measurements to your PV. The second one I thought would be really interesting to have is the TMP007. And what it does is it uses infrared radiation that's emitted from an object, and it picks up on the IR, and it actually is used as a contactless temperature measurement. And it also has its own internal MCP9808 integrated. So what I did was, I can get my own temperature at the entire ASMS, kind of like what I wanted to do with the 9808. And I've actually got this as a means to project, or not project, as a means of collecting infrared radiation and getting very accurate temperature readings from the thermal base plate for calibration in the beginning of a test setup. You can put anything you want on there. I put my hand out there, it'd be at 25 degrees C. You can heat up your cell, you can cool it down, and it'll give you very accurate temperature measurements. Over here, what I have is some empty space, some empty real estate, because I have here some other tiny boards that I'm going to be working with and making even bigger boards here on the back end, which would be, this is an ultraviolet sensor, and I have some plans in the works for this, and this is the UV sensor that I had beforehand. Uses an analog output, basically saying in terms of the voltage, it interpolates the voltage into some kind of UV index. However, I want something a little bit more precise. I want something in the UV spectrum of, in terms of intensity levels, so milliwatts per centimeter squared would be what I'm looking for. And really what I'm trying to do is quantify any kind of bleed in that I have into different spectrums in my black box. So if I'm getting zeros all the way around for UV, and then so I'll put UV over here, maybe IR over here. Be a little different setup over here with the IR, but that could be, not IR, excuse me. Oh yes, IR spectrum. That could be something that I'm looking to do later on. As you can see here, everything's kind of centered around this assembly. So what I had done was, just actually when we would take it out, I have some finer pictures of me building the whole thing, and it goes together in stages, but you could just unscrew these and it declamps, I guess you could say, the laser, and I have a harness all wired here neatly on the side for the test phase, which eventually I'm still in breadboard phase, so I want to make sure everything is working, and then I soldered everything correctly. I also used a silicone gel on the back end of this, non-conductive silicone gel for electronics. It kind of is like a little bit of Corban 27 in terms of its properties, but it has a 24-hour cure time, so definitely a lot longer to cure. But again, like I said, non-conductive, so I can have all this stuff together, and it's insulated, which is really good, and doesn't really add a whole lot of weight. Now, there were some things that I was starting to notice that were a problem. I'll run up my code here, and I'll kind of give you an idea of what I was working with. So the code that I have generated says that, run through, I have this for all of my setups. It says, all right, it's loading. It gives the sensors time to load. It gives everything kind of a chance to warm up before it goes right into its working loop, which is just my void loop, which just runs again and again and again in my C++ programming. Well, what happens is I also have an if-else statement in there that says exactly if there is a problem on the I2C bus, which is something that I'm starting to use here because I have a lot of I2C devices, and I've used this term before, but it's inter-integration circuit. It's from Philips Semiconductors, like in the 80s. It was something that was conceptualized and done. So it's nothing new and earth-shattering, but it's essentially a master-slave relationship. So I have a master, and then I can treat these individual breakout boards as slaves. And it's a serial computer bus, and it's basically broken down into serial data and serial clock. And each device uses a 7-bit address. So I have an I2C scanner that actually goes through, and I can find out the address, like this LCD, and then I started using the Shield. It uses an I2C comm protocol, and this one is 0x27. And these, the TMP007, well, it was like 38 or something like that, and then the 53LOX was 0x29. All I have here is that I have an externally mounted reset button so that I can reset this without having, from the outside of a configuration or box, wherever it's housed, without having to just try to find this little inaccessible push button for the reset. And we'll see why here in a second, because it's really good for troubleshooting. So let's fire this thing up, and you could see it running through its process, initializing its sensors. And it's telling me that I have an error at the TMP007. So I'm not sure exactly what happened, but I was messing around with a whole bunch of different things. I was running my I2C scanner. I was making sure that my pull-up resistances were accurate. Right now I have a 10K from the VCC line to the data and to the clock line independently. And I'll explain more in my circuit diagrams, but it's nothing, like I said, earth-shattering here. This is I would say the I2C comm protocol bus, and connecting a bunch of different things up on that single bus is pretty straightforward, but that's why I started running these issues. So I got into my multimeter, and right now I have 5 volts running across that line. So let's go through VCC to ground, if I could get my hands steady. So just under 5, and then to the data, just under 5, and then clock was showing me 0. So right now there's a fault going somewhere between the VCC and SCL, or just in general, the the serial clock line is just burnt out or something like that. So I reached out to Chicago Electronics distributors to see exactly what was going on. But in the meantime, I'm waiting on another one of those because I think it's a very useful tool to have. Right now I could eliminate this, basically just put slashes in my code and make it as a comment so it could show its boot up. But really what I wanted to do is kind of show you some of the troubleshooting techniques that I use in every day, because these things pop up just twice a day, 3 times a day, and sometimes it's as easy as I didn't solder something correctly, which I really try and avoid. That's probably gonna happen once, as opposed to wiring something on the breadboard incorrectly. I'm always about check, recheck, but I wanted to kind of give this as an update, as a cue of I'm working on different things, but these are just some of the errors that and issues that come up as part of the day-to-day running through the project, but there are lots of things that I've learned in the classes that I've taken thus far, i.e. Three-phase power, complex power, faults in a line. How do you not only recognize that there's a fault in the line by the numbers, but how do you learn how to take it a couple steps back and make it easy for the user to say, how do I program this and put it right on the LCD screen so you know exactly where to isolate it. So this was something that when I was in chapters 8 through 10 in the Power Systems 2 class, that it really got me thinking and thought to myself, well, I should really start programming in faults, where they're located, how to take the fixture out. Let's figure out exactly where the fault is. So right now I know I'm having an issue with my serial clock, which is why I'm not registering an address, which is halting up the whole program right now, which is what I wanted to have set up because I want to make sure everything's working before we go into different kinds of phases. So I can keep resetting this thing all I want, and it'll still halt and tell me that I still have an error there. I could unplug it right now from the breadboard and it'll still do that because it's not connected, because the program is saying that I want you to keep moving on. But because it would take just a few minutes here, I could go in through there and, like I said, cause a bypass, I guess you could say, so it could still run up and do all these different things. But I'm going to save that ASMS update for a little bit later. The main reason I did want to fabricate this was because if we take a look at this setup, this is where the laser used to be, housed right in here. It's just a standard little clip that I made. You can just kind of stick it in there, angle it however you need to, and then it would maneuver across the cell. I think we remember looking at that. This hole was actually where I mounted the proximity warning system previously. I don't think I'm going to continue on with the proximity warning system. I was going to replace that with a set of two VL6180X time of flight measurement indicators, very similar to the 53LOX, except they have a much shorter distance that they can be used, about 150 to 200 millimeters, versus the 53LOX is good up to about 1200 millimeters. So a substantial increase. However, this integrated circuit, I love these ASICs, the application-specific integrated circuits that are available now. They're kind of expensive, but they're definitely worth it, I think. In this case, the 6180X is also has an independent lux sensor integrated into it, which I thought would be kind of neat to have. So this way you could just, instead of those big two clunky things, you have two of these on each side. They kind of show you exactly where you are in relation to any other kind of obstacles or any kind of impedances, and it stops the program. However, the tact switch that I have here is working very well as a good homing mechanism, and I think that if I only have this program from here to here in terms of 800 steps like I talked about before in the BAPSIS, I think we're good to go. Last little thing I want to talk about is, because the ASMS I'm ahead on, I want to make sure that I've at least started on something, so this way I can at least put it on here, start getting an idea of what my measurements might look like, and then kind of move forward from there. The last one was I finally got my membrane type keypad in. It's a 4x4 keypad, and I can have it programmed any which way I want to. But essentially what I'm going to do is, this is just a regular CNC style that I got again from Chicago Electronics. Like I said, the long lead time is definitely well worth it for some of the quality of products that you get, as opposed to, you know, a couple days shipping from China. I don't really know how I feel about some of those parts that I've gotten in. I've had a lot of shorts go and a lot of components go bad very quickly. So I'm eager to try this one out. It's got lots of different lines I'm trying to mess with and figure out what's what and who's who in the zoo. But what I'm essentially going to be trying to do is set a command type, so set angle, and then you just put in a three digit, so 45 degrees 045, and then you hit start, it'll just go to that position. Or you could stop it partway through. Lots of different functionality with this that I'm really excited to start using. And really what I think will be do to add an extra level of professionalism and user friendliness, I guess you could say, for someone looking to get into this test equipment and say, well, I've used CNC before. Oh, this is really easy. All I want to do is it's just one axis, or two axes. Later on, set it up, could be really easy, user friendly, and that's essentially where I'm trying to go with this, and also easy for me for having to troubleshoot things, as you've seen I have to do on a daily basis, because this stuff isn't perfect the first time around or second time around, which is really important for the experimental phase, going through the breadboards to prototyping phase, using a lot of my PCBs that I'm putting together specific for the jobs that need to get done. So, as always, any questions, please feel free to shoot me an email or give me a phone call. It's starting to really come together. I might, towards the end of this semester, what I might actually start doing is just trying to build an actual enclosure, see what kind of measurements I'm getting, set up a lux sensor down here, see how many lumens I'm getting on my solar cell based off of what's in the visible spectrum, see what my visible spectrum responses are, just to at least get some kind of data and say, hey, if I'm on the right track or not. But good steps are being made and progress is being made, and I'll of course keep you guys updated on what's going on. But thank you for your time and your patience, and talk to you soon.